wanted to do a quick overview of how I use Spack for developing LibPressio. So the first thing I'd like to kind of talk about is that I don't use the typical Spack entry point in order to get Spack into my environment. Instead, on each system that I use, I have a command called use build. So what does use build do? Usually it does some slight modification of my path. It may unset certain environment variables that are responsible for finding various software that otherwise might be installed in my system before actually calling the command that loads Spack itself. On HPC systems, it will oftentimes select a specific Spack instance for a specific machine out of a collection of machines that share a common home file system to ensure that the incompatible compilers that are available on each machine don't influence Spack inappropriately. So now that we've loaded Spack, um, I almost always use Spack environments. Um, so the primary environment I use is an environment called LibPressio Spack. And it kind of has a number of things set up that I think accelerate development. So let's go ahead and look at that. So first, you'll notice is the usage of ccache. So ccache, if you're not familiar, is a tool that allows the caching of intermediate compilation steps to drastically accelerate C and C++, and I believe also Fortran compilation. So ccache is very useful, but in the context of Spack, because of the appearance of the hash in the directory path, it's maybe not as useful as you might otherwise think. Now, there is an exception to that, and the exception to that is anything that is installed via Spack Develop will generally have a consistent path for ccache in order to correctly cache things. So this is primarily important for things that are Spack Develop. If there was a way to turn it off for things that are not Spack Develop, so it just doesn't add overhead or add things to the cache that are just going to get evicted immediately afterwards, that would be nice. But um, this is kind of the first thing that I do that kind of really helps with speed. Another thing that helps a lot with speed is the use of mirrors. So I don't have the mirrors configured here, um, but if I look here, you'll see that I have a recent copy of the developer tools mirror binary cache enabled and configured for use on my system. Another thing that I use is I currently use the Spack Env Depfile facility. So if we look at the if we go to the Spack environment, we'll see that there is a makefile. This is generated with the Spack Env Depfile -o makefile command, and then it can be built. I'm really looking forward to the improvements for parallel build because there are some warts with the env Depfile syntax, most notably in the context of incremental compiles. If you don't have an incremental compile, or if you're doing an incremental compile, what will happen with Spack Env Depfile is that it will just delete. It won't detect that the packages have actually changed because it uses touched files to indicate whether or not a particular dependency has been remade. This means that it doesn't invalidate things, so you end up rebuilding more than you have to because you have to then do a clean, which doesn't actually uninstall everything. But when you go to do your build, it will have to walk through. In this case, this is the other problem, is that it will become out of sync. So let me just go ahead and regenerate that file. So go ahead and make clean again. And then we can go. And generally speaking, again, this does the right thing, but you're going to end up with multiple updatings of the view that are unnecessary. And then it's going to spend a lot of time basically re-registering all of these packages through make in a way that seems kind of unnecessary. So while this works and it's pretty useful, it's maybe not everything that you need. So how do I handle the intermediate build case? So the intermediate build case, what I typically do is I will run Spack install. So once this is finished re-registering everything, and again, this kind of stresses why having some improved incremental build for this mode would be very helpful. So finally, we're to a source file that is involved in the incremental compilation. So it's building a copy of LibPressio. So currently, I've been working on a feature that handles how LibPressio works in the context of static compiles. But then, as you can see, after LibPressio, there's actually a number of additional packages that exist above LibPressio that potentially have to get recompiled. Um, so those are kind of happening now. And while they are smaller, there's a substantial enough number of them that the recompilation is somewhat painful. Um, so typically what I do is if I know that I'm making a change that is API compatible, what I will do is I'll just do spack install libpressio, and that'll only, A, it's a lot faster, but B, you'll see that it immediately just stops at that one particular package, even though there are many other packages that are above libpressio in its hierarchy that are automatically getting recompiled, but we're just kind of reusing the existing link of them, which means that we get fast recompilation, and higher level tools such as Pressio, which depends on libpressio but is in a separate package, um, can take advantage of those changes. Now, the next thing that I'm going to talk about that's kind of really critical to the workflow is what I'll call using or fixing the concretizer. So as I said during my talk at HPSF, occasionally the concretizer makes some really bizarre choices. So oftentimes um, we'll need to make some changes. So a good example of one way that I would do this is I want to ensure that a particular compiler is used. The reason for this is uh, I'm on Fedora 42, which currently uses GCC 15, which is currently unsupported in the latest version of CUDA, which is needed for some of the packages in my environment. So because of that, I'm going to use the GCC compatibility compiler provided by Fedora. So it's 14.2.1, and I specify it as so. The other thing that I frequently need to do is because I'm using a build cache, I often need to use the concretizer section of Spack to exclude certain packages from the build cache. So the two packages that are the most problematic are FMT and LLVM. LLVM, because it takes so long to compile, is particularly annoying. However, there's currently some paths in LLVM that don't get relocated on package installation, dealing with how it finds its copy of libstandard C++. And if you don't correctly relocate those, what ultimately happens is that you get a broken Clang, which is what I actually need to work um, for this. It's also even kind of more annoying than that because it also breaks things like Clang tidy, which is actually what I'm using in the course of my build. FMT is also excluded from the build cache. That's because FMT, like Google Test, is extremely tied to the ABI of the specific compiler that is used. Um, and it changes its ABI very dramatically depending on which compiler is used. So you can get very weird linking errors or other problems if you try to use a compiled FMT that was built with a different compiler than the one that you're ultimately using. If I had my druthers, FMT would just not be part of the build cache. It doesn't take that long to build, and it's almost never going to be correct. With regards to LLVM, we just need to figure out a better way to get it to correctly invalidate things when it's building. That would just dramatically make things a lot nicer. Another thing that you're frequently going to need to do when you're building with Spack is you'll need to see the logs. So there's a handy logs command. I then often look at that in combination with grep. So I will maybe grep for, let's say I wanted to look at the open MP uh, OpenMP to see the information from the logs related to OpenMP, for example. To look for something that I know is actually in the logs, I could instead look at the logs for um, register, which is a new feature that I'm working on. And I can see that it correctly generated documentation for register, um, as well as that the LibPressio manual register file got included in the build. So that's the new feature that I'm currently working on. Another thing that I do with Spack environments is I make very heavy use of the develop functionality. So um, this is not all of the packages that I actively work on, but this is the active set of the packages that I currently work on. So if we look in my current directory, we'll see the entire list of packages that I'm currently working on. And the subset of the ones that are listed in spack.yaml uh, are the ones that will get recompiled as I make changes. Now, why do I do it this way? Why don't I just have every package listed as a develop package? And that's mainly because of the number of rebuilds that get triggered unintentionally um, in this kind of a setup. If Spack was more aware of ABI for a package and could handle that it doesn't necessarily need to rebuild a package if the ABI for the package below it hasn't changed, that would be fantastic. But until something like that happens, doing incremental compiles is a lot faster the fewer Spack Develop packages you have. So I only have the set that I actively am currently working on listed in the development list. Another thing that's really important for me is having good tooling in the context of my IDE. So LibPressio is primarily a C and C++ um, programming language. What you'll notice here is inside of these directories. So let me grab one that actually still contains something. There is a file that is included here called compilecommands.json. So this file is generated if you manually set cmake export compile commands equals on. And if you're using the command line, you can say cmake-d this if it's not already set in the cmake file, and it will create this compile commands.json. Now, Clangd can utilize this file if it knows where it is. So essentially, I create a file called clangd that Clang knows about that tells it that its compilation database is in this particular path. So this is a relatively simple file. It would not, for CMake packages that are being developed, be very hard to automatically spit out this file. That way it's automatically in the right place. What makes this maybe a little bit annoying is if you're doing matrix builds that are each using the same develop directories, which is another thing that I do actually do. Then you potentially would have multiple of these that would conflict with each other. A good example of why you might want to do that is I've been working on this patch from I'm working on evaluating this patch that came from the community, adding HIP support for mguard, but I need to test that patch against multiple versions of the mguard source code. So if I don't currently have this checked out as a develop package, but if I did, this trick would not work. So there would have to be maybe a little bit more thought here, but this generally works pretty well. Another thing that's pretty useful and important is having good debugging information. So for having good develop information, CMake has the build type attribute here. And essentially what I do is I require on the set of packages where I want to have good debugging information, I require that the build type be set to debug. And then additionally, I go down and make sure that it's in the list of packages for develop. So why is that the case? So Spack by default deletes the source directory, so all of the dwarf information gets lost for packages that are not develop packages. But for packages that are develop packages, all of the source remains available and all of the dwarf info remains valid. So in an ideal world, we would do something like using split dwarf information. We'd have what's called a debug infod server, which would provide that information for a corresponding build cache. And from talking to the kitware folks this week, my understanding is that CMake is getting some better support for split dwarf, which means that this whole process would potentially be even easier to implement. The last piece that I want to talk about here is with respect to unit testing. So I can go to a package that I'm working on, and in here, when I want to go and run testing, you'll see that in my Spack package, there is or you'll see that in many of my packages, I use the build testing command that CMake provides as part of its ctest include, which is responsible for whether or not you build additional tests. So I need to be able to set that. So in order to support this use case, I make use of two features from Spack. So one of these features is the Spack repos function. So I have my own set of packages here. And if I edit the LibPressio predict package, you'll see that what I'm doing is I'm importing the LibPressio predict package from built-in, and then I'm adding some additional things. The key thing that you'll notice here is that when dev path equals star, I know that I want to build the tests. Ideally, what I'd be able to do is I'd be able to say if self.spec.satisfies dev path equals this, and self.run tests. But currently, there's not a good way to specify that you want to do a run test for an intermediate dependency without turning it on for a bunch of other packages. So if tests could become a variant that would allow you to set it for the specific packages that you need it for, that would potentially be a lot more useful for me than this, but this is what I kind of do as a hacky workaround for now. After you've built a package in that way, then you can kind of come back with ctest. So I do spack cd-b for the build directory of LibPressio predict. And then from here, I can run ctest and all my test cases passed. I can also from here run specific subcommands, but ideally there would be a way that would allow me to interact or interface with ctest from Spack. And it wouldn't be that hard to write an extension that would facilitate this kind of usage. I just haven't done it yet. So that's about it with respect to how I develop packages. I look forward to any questions that you all may have, and thank you for having me at HBSF.